Alright, Internet strangers, welcome back. Gonna get a little work done. I spent the morning messing around with updating a server and chatting to a customer about some performance issues they were having with Super Dev Mode. Learned some interesting things, or not really learned, but confirmed advice that we typically give to customers when they are trying to make Super Dev Mode behave and be fast and all those other good things. And one of those bits is you don't want to have lots of errors in your build. Git lets you get away with it. There's a strict flag though that says, hey, make sure that I don't make mistakes like that. And removing all those dramatically improves performance. It's not one at a time. You know, each one of those little ones by itself is not a big deal, but they stack up over time. And the other cool thing we found was that static or public resources, one by one, they're not a big deal. You can have a couple of them. You can copy a few files over and say, hey, I'm going to need these in the browser. But first of all, if you have thousands or tens of thousands of them, it will take an appreciable time to copy them over every time that every time that Super Dev Mode updates. And I'm pretty sure that old style Dev Mode had that problem too. We didn't dig in and check that because, you know, practically nobody uses that anymore. But the flip side is, it turns out this is for a project that doesn't even use the resources on the client anyway, and has them on the server class path. So it could have just loaded them there, but it didn't. So that's not terribly effective. Justin's complaining that I'm already talking now that I'm here. Yep, I probably should do that. But I'm not gonna, because we usually get like 5 people here, and we get more views on YouTube. So if you're gonna watch this on YouTube, you know, you don't want to watch the lead-in. So take that, Justin. Also want to mute Slack. All right. Anyway, this was my lead-in to, hey, all right, let's get some work done now that I'm getting settled here. Seeing if anybody wants to show up and see about HTML templates, because I haven't been talking about HTML templates. Yeah, sure. All right, if you want to sign up for the trim the video thing, I can't be bothered. At some point in the near future, I want to get back to actually producing content that is meant to be produced, you know, not just creating, hey, I'm going to, you know, let people listen to me drone on, but actually saying, hey, here's some content. Let's have it stand on its own. But not today. Not this month even. Maybe next month. Maybe we'll be back there again. So this is HTML templates. Just for people who haven't seen this, because it's been a little while since I played with it, the basic idea here is using Java 17 multi-line strings. We can have a template annotation that has its string take up multiple lines. We can tell IntelliJ, hey, this is HTML. We can say, hey, here's a class that's going to bind some stuff here. It's going to be a view. It's going to have this order view model, which will have some properties of some kind. You know, don't worry about the specifics here. But then we want to actually generate this HTML and say, well, this tab panel is actually this variable here, which is another type, which has another template. So we can nest these templates, and we can reference data. This curly brace here will say, hey, I've got some items property in my order view model. Each one of those items is an item view model, which has some properties on it, SKU, name, and description. And SKU will be made available here. Because we are going to loop here over each of the items, we can also have access to our index in the loop, the length of the list, and even things outside of the loop. So we can actually reference things outside of this new scope we had added here. When you create child components, we can always say, hey, I've got some property I want to bind to you. And so the child component, in turn, needs to have its own properties. Here we see the difference between a view, where I have some other object that I'm going to point at to be my view model, and a component which sort of stands alone to say, these represent my attributes. If you set my attributes, I will use them and rewrite my own DOM accordingly. And if something changes in the UI, where the user types something in, this will propagate back out again. Now what this is missing here is an onChange handler to say, hey, this changed, go ahead and trigger this here. We do have that sort of kind of wired up at the end here, @change equals onChange, but we haven't figured out the specifics of how do we know the new value or the old value? Do we have an event passed in? Can you scope in things like placeholder to pass in directly there? Or are you expected just to reference it here? There's a lot of details that we don't have figured out once you get into the weeds. But the basic idea of how does the template work, how do we introduce new scopes, and how do we nest templates and things like that. We've got the basic piece worked out here. So this all here boils down into a language. The language is defined using Java CC. So that it goes through and says, okay, here's what all these different details about where strings are and what less than and greater than symbols mean in order to represent HTML, and what an HTML entity is. So IntelliJ is collapsing this for me, but it's actually ampersand AMP semicolon. So that gets matched as a named entity, which will be a hash, and then an HTML entity shows up where? Right here, ampersand, HTML entity, semicolon. An HTML entity could be a hash and then a decimal entity, a hash and then a hex entity, which is going to start with an X, or just a particular name, which could be A to Z, multiple A to Z characters, in this case AMP. And we're going to leave it up to the browser to say, okay, exactly what entities actually matter. We're not going to validate this at this time. Figure out what it should be. And then we build these up. So once we've got all the syntax worked out, we can build up what it all means. That there's a document at the top level. Document consists of a top level tag, and a tag in turn is either a DOM element or a component. A DOM element and a component, each of those have something where they're going to be some kind of a less than tag identifier, your attributes. Either you're going to be self-closing or you're going to have contents, and then you're going to have a close tag. And the contents themselves, in turn, will be a tag. So you can put tags inside of tags. And we've got a star here to say you could have many tags. You could have references, you could have text nodes. For the most part, this language has survived our testing and putting it together. It already could parse a lot of things. Looks like we made a small change here. Looks like I just made this more specific. Change it from a class identifier to an HTML identifier. Oh no, it could be either one, HTML or class identifier for its, what are these? A component. Why could that be either one of them? Oh, I see. It used to support a close tag of an HTML tag, which doesn't make any sense. Components are closed by components. You know, open and close have to match. HTML tags are closed by HTML. Okay, so that's pretty good. That survived pretty well. The next piece we did was to say, okay, so for this kind of a template here, if we were to generate this by hand and try to have this implement view, which requires these two methods, and has DOM element, which basically says, hey, turn all this into a DOM element so that someone else can take that and inject into a page. We have a handmade implementation here for what this could be. There's a constructor. It's got our methods to say set and get the view model, and then as DOM element. And when you call set view model, it's going to call this helper that does bind. We don't have all the details worked out, but here's how it's going to create all the stuff. And it's not all the details, but it's getting pretty close. And then we also have the generate implementation to say take that, automatically generate based on this Codegen, which we'll see in a minute. What this should look like. Looks like I need a modifier on this to make it private. Same kind of constructor, same kind of get and set for the view model, same kind of return the DOM element. And then here is the generated bind that says, okay, create each of the DOM elements I want and the components. When you make a component like this, we're going to set its attributes one way. When you make an HTML element, like this DOM element button, we're going to call set attribute to assign those things. So it's got the context to figure out how it's assigning these different things here. And then when we have a tab panel like this, we should probably lowercase that. We'll get that in a little bit. We can add children to it. We have a notation here that will say how do you find those children and add more things to them. And then you can say, oh, it automatically knows to grab the root and grab the DOM element of that tab panel and append it. So it knows that because this is a component, it will have an as DOM element method that we can call, and we can get this. And I believe things actually build at this time. Let's try it out real quick. Nope, I'm in the middle of writing something, so it doesn't compile right now. Okay, cool. So we we left off by creating this new class called Template Resolver. Actually, I may have done this off stream. My streaming schedule is kind of varying as my home life changes and evolves. Got a kindergartner who is apparently a hockey player. Loves playing hockey, not good at it, and now has an after-school floor hockey thing. So, which makes my Wednesday afternoons stretch a little longer to get some work done. Anyway, so we've got this template resolver that's going to propagate into this generate bind method for hasDOM element. The idea here is that we might generify this to say, well, what if we weren't creating a hasDOM element? What if we're creating a GWT widget directly? Or something like that. Or an is element from Elemento. Is that is element or has element? Anyway, this is right now the one size fits all, so we got a little very specific. I wrapped up, let's see here. Resolver is what we're going to use to say, hey, how do we make our components? Because the component itself needs to say, how do I look up what my component is based on its component name? And so just for context here, that means the only context we have here is the word tab panel. The resolver will have the knowledge of what was passed in here for tab panel. And maybe one day we'll have an aliasing thing to say, hey, tab panel, I'm going to refer to this as something else because I have two different widgets in the same panel called tab panel. And that might be confusing. All right. So that's one of the things we're going to have to resolve. Another one is find the children field. This is a new annotation, which shows up in the same package as our template annotation. So, right, this has got a template annotation. Next to template, we have children. Children is used to say, well, we got docs right here. It's a marker to indicate that some observable property of observable list of T field will hold DOM element children from the class's current template. In this case, T can either be a specific component type, which will be enforced at compile time. Note that it isn't yet, but we'll get there. Or can be a no DOM element to allow any DOM elements to be attached. So we can now say, hey, where should I be writing these children? And the case where this matters is, so for example, tab panel, we need to be able to add tab item children to it, but only tab items make sense as children for tab panel. So we have to have multiple tab items. And so in the children property, which is annotated with children, it is an object property of observable list of tab item. So when we get those new ones, those new children, we are going to automatically iterate through them. And this is the tab bar at the top, the tab strip, where we have an item that says, hey, it's an item, and it has a close button maybe, and an activate button. And only the active child is rendered. So active child is like a private one to say which child is the one that we can see right now. We could do this differently. We could wrap these tab items up in a model that says, hey, only one can be active at a time. But this is just how I modeled it for experimentation purposes. And then active child itself is a tab item. So whenever this is set, this binding here needs to say, oh, the property changed. Let's rewrite this. Haven't figured out how to render that yet, but that's the plan. But then in turn, tab item, which is not explicitly referenced here, but we have it here, of course. A tab item is really just a div around some contents, but then it has some metadata attached to it. So it's not only the DOM contents, and notice it's actually DOM nodes. It could be just plain text. It could be elements in text. It could be just elements. It could be just one element. We're going to wrap that up inside of a single parent element. That way we can treat this as if it's just one single thing, which would just normally be the root of the div plus whatever contents to get set in there. And then we've got the name of the tab, the icon, and closable. And hypothetically, we could have, is this active or not? Oh, we do. We do have, is this active or not? And then class name is based on whether it's active. So it's a little weird to spread that state between these two things. I'm not going to worry about it right now because in theory, our observable stuff should make them, when you modify one, it'll modify the other one. We don't need to think more about it. There's no other state to keep track of. Which, after all, is the whole point of a lot of this HTML binding stuff, whether it's React or Vue or Svelte. Whatever it is you're doing, we want to take the developer's hands off of the state itself, the state of the widget, and just have you control the state of the data. And the data then needs to drive the activity of the widget, the UI. And then naturally, because that data now has to have, hey, is this changing? Who do I notify? Things like that. It really doesn't make sense for that to be a DTO or a Java Bean or something. So you have to have one more layer of, okay, well, I got data. How do I get it in there? Whether it's a proxy. In Java, we're going to be using these binding property stuff. This is something Justin put together, I don't know, last summer. Seems to work. I think there's a few quirks I've got with it, like computed property seems weird to me that you can't, that it behaves as though you can set the property, but it really won't work if you try to set the property. Anyway, we need to use it in anger more than just experimenting with it like this, and then we'll find things out. So just for giggles, let's take a look at what the tab item impl looks like right now. Right now it just makes a div, and it says bound text node. Okay, so it does not understand that this is the wrong one. It does not understand that contents, as a type here, contains a list of DOM nodes. It thinks that if you see a $sign curly brace outside of any tag, just as a plain top-level thing here, it's always a text node. So that is very much going to be wrong. Bound text node is the wiring that says, okay, take some property and listen to it for changes, and whenever it changes, take the string value of it. Because after all, if you got a number or a Boolean, you want to get the string value of that rendered. But if you have a DOM element, it's going to be pretty useless to do string value of a DOM element. So we need to tell this not to generate this. This is just plain wrong. Okay, so that pretty much gets us back to why do we have a children field? Who's going to be calling find children field? How are they grabbing that accessor to append text or to append another model, which could be another DOM element or a component, and then the code gen along the way. So little by little, we're getting more of the actual logic that we need to have here, and just these tiny little snippets of, this is how Java Poet encourages us to write code. We've got a type token here, and then a literal, L is for literal, and then another type token, and we'll say it's the component type, which is the abstract type of tab item. And then timpl, for now, is how we're figuring out how to take the component type and turn it into the implementation type. We're just always going to assume implementation until we get some other answer than has DOM element. And then L is going to be the name, because as we saw over here, we want to have different names for each one of these fields. That way they are vaguely readable as we wander through them. And this in turn comes from a namer. A namer is a simple little class here that keeps track of what names we've got so far, and it makes sure that the first name is always root, because then it makes it easy just to bind this up as a field. Okay, that's our summary. Nobody's talking about anything or asking any questions, so I'm just going to press on here. We're going to fix this view model and make it private, because it should be. Here we are, view model. Nope, that is the getter. Here's the field. So we need to say that this field is okay. I think that's the only quirk I noticed along the way. We always synthesize overrides, and that's because if there's ever a mistake in generics or something, this will fail to compile rather than just be the wrong implementation. So we really prefer to always have those override annotations stuck in there. Okay. All right. The resolver, the last thing we were doing here, and we left it in a state where it didn't compile, is resolve view model reference. And I have no actual call to this. It looks like this is the code that should say, if I have a reference like item.skew, how do I look up where I can find that? Or recipient.phone. So just context here, the outside scope is order view model. Once you get inside of this tag with the repeat contents, there's a second scope, which is the list item. So repeat contents introduces a scope, which is a loop item scope of type T, which has an index, a length, and an item, and that's how we get index, length, and item. But if you reference something that's outside of the scope, it will jump up to the outer scope, which is the order view model, and say, oh, well, never mind, I couldn't find it here. We'll go up here and look for, yes, there it is, a recipient. and a recipient in turn better have a phone. There's the phone. So what this code here is going to do is it's going to return a view model reference, which will have the accessor, the chains of dot get recipient dot get, or sorry, it'll be dot recipient dot get dot phone dot get, and it'll need to know the type, whatever it came up with there. Presently, this is a declared type. Pretty sure that's wrong because it's possible that you'll have int property. I think that we're not exposing the properties themselves, we're exposing the value. We'll need to figure that out. But then if you have these things chained also, we're also going to need to keep track of the set of all properties that if they rebind, you need to pay attention to. So what that means in specific, the specific context is, if the phone changes, we pay attention to that. If the recipient changes, we pay attention to that also. So if either of those properties changes, we need to rebind this value here. If the entire order view model changes, of course, the whole bind will run again, so that's not our responsibility. This is only responsible for watching recipient's phone property and for watching recipient. And if either of those changes, we rebuild this particular DOM element here. And recipient.phone in turn is a string, I think we said. That's not it. Recipient view model has a string. Phone, yes. So that will just get rendered as a text node. So at some point we need to stub in here, hey, you need to be able to access not just the accessor and the type, but also the properties to listen to. All right, so for the time being, I've got this child. The idea being we should be able to access recipient and get its view model reference, and then call get on it, child on it, to get the phone, to get its view model reference. And we should accumulate the parent's accessor along the way. So now it's a question of, do we need something to reference the property itself or just the value? And I think we probably need both, because we need the type of the type of the value and the accessor to get the property so we can listen to references of it. It'll probably make more sense once we actually use it in anger here. So this get model here, this get call here, we'll look at our stack, which again in this context is first we have the item itself, and then we have the parent, which is the whole thing. And we'll go up the stack and say, okay, for each reference you find, look at all the fields that are available. If any one of those fields matches the key you're given, then we found it. Otherwise, we failed. We probably want to error out there. And now to actually use this, right now we're calling get somewhere. Nope, no, we're never calling it. Okay. Now we want to say split our reference here. And we want to loop through here and find the child. So we probably want to grab the 0th one. That should be impossible. Now we know there's at least one entry here. Why don't you like reference? Am I already using reference somewhere? Oh, right here. I've already got that there. Okay, so we get the top one, and then we want to loop and get all the rest of them. So let's make this a 4i, so we skip the first one. We'll change this to a indexed for loop. We'll start at 1. And then we'll say Okay. Now we definitely want this to throw because it failed to find something here. Now, we do have one other failure mode here. What if there is a recipient both at the top and the bottom level, and we end up resolving it at the top level first, but then it turns out that a nested property doesn't make sense there. So in other words, if this had an item property, it might be the right one to use, and we can't tell just from looking at it. This is going to matter when you start nesting loops. Repeat contents nested in repeat contents. So I think we're going to have to backtrack in that case. And I think we're going to handle that with a to-do. We'll put it up here, I think. Well, I guess it does need to be aware of the stack. Yeah, this whole thing probably needs to be one method. We'll just make this private for now and figure this out later, because we need this get call here. And child is going to do what exactly? Child just looks for these children here and then constructs a new one, and it nests automatically. Yeah, so it looks like we need this to be here. Okay, so we will probably inline this method up to here. We got a hotkey for that. There we go. This isn't quite what we meant. And that was what it was trying to complain about. All right, let's undo it. Let's put a throw in here for now, or an option. Let's see. Because if you fail to find it, we got to go up the stack again to find it. Do I use Spring Framework? Not on purpose. I won't say I avoid it at all costs, but I used it like 12 years ago, and I'm still not a fan, unfortunately. This is totally unfair. I just found it to be antithetical to actually getting work done. I am sure there are situations in teams where it does make sense. I've heard great things about Spring Boot, but I have found that dependency injection, at least for projects I've been involved in, doesn't really need that much pre-built infrastructure for you. If I use an optional, this is not going to make it any better. If I throw down here, it's not going to make it any better. Let's just inline it. Because then it's gone and we can always rewrite it later. And this actually should go inside of here. That's the trick that's going to happen here. If viewModel does not equal null, break. So if you found it, then we will continue here. Child can throw. No child found with... Yeah, I guess we want this to be an optional. Okay. We'll figure that out later. I'm not really worried about the scope problem right now. Remove if statement because it doesn't do anything. Okay, so the logic again is we go over the stack. We find the fields in whatever the current element is on the stack. We check each of those fields. If any of those fields match, then we use it as our current one, and then we loop until we find the right one. And if we fail, we continue. So let's go ahead and fix this now. This doesn't look so bad. We're very close to having this right. The only problem is we might want to accumulate errors as we go because a user isn't going to necessarily understand what their reference was wrong about. And now we can just do return field down here. Oh, I see, because we still got to map this. Okay, okay. We can do that. That's easy. And that's going to be F for field instead. Oh, come on. Just want to turn this into a return. So F for field, we'll put this whole thing here. This is now impossible. We're now returning that. F doesn't need a get on it anymore. We're just going to do an as type to say, hey, here's the type you're going to be. We'll figure out later if declared type even makes sense there. We're calling this up here, and now we have a optional we need to assign here. Come on. Problem is we don't want to continue this loop. We want to continue this one up here. To say try, no, this one up here. There's 3 loops in here. Actually, you might continue, no, you've already found one that matches. You can't have another one that matches. There can only be one that matches. Which suggests we should be streaming and filtering here. And only once we get to the end of the loop do we return. So we're going to use what do you call it? A reference, a tag, a label, a label. So very rarely do I find I need these, but it does happen. We could conceivably make this a for each and this a loop. That way we could disambiguate between return and continue and throw. And if you throw, then you get outside of this and we do a continue. But I'm not going to do that. We're just going to go ahead and let this be a little hard to read. All right. Let's rename this to something less irritating. The stack represents the various scopes. So we've got the scope of the items and then the top level scope. We could have many levels of scope items in there. So now we'll work our way up and check each scope, ask the scope for what fields it has. If you find a field that matches your first key, we say, okay, this is our view model reference. And then you loop through the rest of the keys you have present, starting at 1, since you've already looked up 0. Content equals, did we not actually assign the 0? Oh, I see, we can already be sure that it was the right one. So we don't have to look it up again. Nice work, IntelliJ. That is the right way to refactor that. And then we get down here and we say backtrack when a reference is missing. Okay. Try backtracking further up the stack. Right? Yeah. Okay. That is now future Colin's problem. He's a jerk anyway. And you know when we get to that, we'll be saying the same thing about, he'll be saying the same thing about me. All right, resolve directive is a problem we don't have to deal with yet because we haven't implemented directives. Resolve view model reference. So now we need to actually try and use this and see if it makes sense. So let's go back here to the component model and see what we have next. We've got some places where we need references. String constant. Okay, so for an attribute, we say either you have a string constant, you have a single reference, or you have a complex property. And what that means is you've got a string plus a reference, and we need to bind that as just one single thing. This is harder for attributes than for DOM contents, because for DOM contents we can just make a text node for each child, but for an attribute you've pretty much just got one string. You've got to get everything to fit in there and make sense. So to do, solve for the type of the accessor and coerce. That means that this attribute here, because we're in a component, we need to make sure that you can actually set strings onto there. That sounds like a not me problem right now because it works already as is, so we'll get that working later. Is single reference. So if we have a single reference here, now we need to say get the reference and pass it in here. We have bidirectional binding, so this is something that Justin had already pre-built for us by the time we got here to say, hey, I've got two different properties, I need to hook them up together. Now because we are ourselves a component, it says so right there, we know that we have view model properties we can access. We just need to figure out how to access them. And we'll get that here. And I'm sorry, we will get that. Is it here? Yes. Here's where we access the reference for the thing that we're going to bind. And here's the thing we're building and how we're going to access it. So attribute model, get attribute name, accessor. This is how we set the components values, the attribute name, for example, tab position equals top. So tab position comes in from attribute name, and we use it to make accessor. And so that's going to get rewritten to tab panel, which is where I lost it. Tab panel, here we go. Tab position. So it's getting rewritten to Pascal cased here. And it's going to say that tab panel's tab position field, call the setter on it with this. Or in this case, that tab panel dot tab position is going to be bound to that view model property over there. And here's where we need to say attribute model get single reference. And here's where we hacked it together by saying all expressions are strings. Your references are a list of references that we build as we go, I guess. Attribute model. Okay, so an attribute model is a model. As we build the attribute, we say, hey, it's got text, hey, it's got references. Get single reference will access just the reference. The reference will be the string, which means we need to take that reference and figure out how to actually get it from the scope. So this is the thing we need to change here. Did I not assign the resolver to a field? Sure didn't. Okay. So now we have a view model reference. Which is our scoped reference, and it will have the nested foo.bar.as, but as a thing that has an accessor like this that we can grab it. We're going to assume that that is magically perfect. And then we still haven't worked out the type details here. I don't think it should matter. I think we'll just get a nice little compile error. It would be nice to say, hey, you got an int property and you're binding it to a string, which is okay. But the other way around is not okay. A string property to an int. So we might try to generalize that a little bit. And then we've got complex properties here, which we're not going to handle yet. Okay, so where else do we want to resolve view? You know, let's just see if it runs before thinking harder about this. DOM element model is going to need this next. 17, of course. I still do enough work with Java 11 that I don't have 17 as my default yet. All right, error writing generated type unrecognized reference recipient.phone. Okay, so that is actually a great error to get. It is not a great place to emit the error. It would be nice if it told us about the annotation and maybe even line and column, but that's harder to do just with Java's own built-in handling here. So let's turn on stack traces and see where we blew up before we attach a debugger to see if there's something obvious we could have done in a smarter way. Looks like we're actually not going to get a nice stack trace here because it's just going to say, hey, Java blew up. We can put a breakpoint on the throw, though, and try to access that. So this is where we say, yep. Hopefully we get the debugger in before it blows up. Perfect. No component registered with, oh no, I guess we're just testing that. That's fine. Here we go. Here's our reference, recipient.phone. It looked at the stack. There's one element on the stack. There's one element on the stack. I guess we're not pushing elements in the stack yet. The accessor is getViewModel, and the type is orderViewModel. The orderViewModel has some fields. Let's do Alt F8. You're not going to be real happy about that. As element. Stack peak type. Items and recipient. Okay, so that worked so far. And then this field here, this should have been the next one to say, hey, assign this to my where do we assign this? We said the scope is now the view reference, and then we say view reference.child. So we should be able to just change child.phone on the end of it. Maybe we can't. Why can't we? Did I return the wrong thing? It's a variable element. Oh, I see. We need to actually grab that and make it a... No, it is. It should be a view model reference. Get enclosed elements gives us the fields. Given a field, we check if the name matches. Oh, we're not actually using that, though. That's the problem. So once we get in here, let's see here. Once we get in here, we found that we could resolve recipient. The view reference is not the scope, it's the scope child key 0. We can assert that that's always going to work. I think this means we can actually make this loop here start at 0. Let's try that. I think that's right. Not going to attach a debugger. Hey, are you planning on releasing new Jackal Maven plugin? Yeah, I'd hope to get further, but that has not been how life has worked for me recently. Cannot find all kinds of symbols. So yeah, it probably makes sense to bump some of these things we're working on to a later release. So item.className, there is no item yet. So that's wrong. We must be inside the scope where we expect item to exist, and that's not going to make sense inside of this loop yet. Okay, that's a reasonable error to have, and this is that's the same one it's going to have over here. Where do we leave off with that? I think the main one we've got is we just got to ship this. So I think, Dimitri, you said you were happy with this incremental stuff. No review on it yet, and it doesn't build right now. So we'll have to figure that out. Oh, I guess it just got canceled because it got stuck. And now there's a conflict in some stuff here. Yeah, so I am happy to release this. I thought you were going to be working on the Jackal stuff because this is just a hack together to say, make Jackal work. The Jackal task here, though, is just slapped together to say, hey, it's kind of, you know, implemented. Do things, copying old JS files. So if you want, we can skip making this incremental entirely. Except the only once issue. I don't quite follow. Do you want something else released? That we can just get a release out rather than a snapshot? And then we'll punt on this. I just don't want it to take that much longer, but whatever. We can do it. Yeah, so, I mean, do you want something other than incremental? Do you want to get your incremental to work? Or should we just ship without it? What do we have since our last tag? July 15th. So we got like 6 months of commits, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's a bunch. Yeah, here we are. Okay, Dimitri, are you going to work on that, or are we punting and not doing incremental? That's the real question, then. Okay, so this won't work at all until we get that next piece in. No, we're just going to do it. Why am I being a jerk like this? Because now we say scope.child split 0. We can just say scope and start at 0. And we've got a whole bunch of other performance stuff in the new Jackal Maven plugin, specifically making closure bundles much, much faster. Getting incremental will make things faster still. We'll only have closure incremental if we punt on your piece there. So you got to let me know. Closable. It doesn't like tab item closable. Oh, it does. Set. What's a Boolean have here? Abstract. Must have a set call on it. Set value. What's the difference between set value and set? Is this like an object versus not object thing? Object property has set and get, but those just delegate to get value. This is readable object property as opposed to readable property. All right, this is one of the I don't quite understand things about this binding tool. We have readable value, which will return a T, and then we have readable object property, which also returns a T. An object property implements both. Right now, Jekyll made a plugin retriggering each building, each save and delete. It's not really nice because my CPU all the time is 100% busy. Maybe we add some manual reload strategy like Gwt do. Yeah, sure. That's fine. Do you want incremental Jackal though, or are we just gonna try and I'll clean up the merge request without it, because that's what it was waiting for. And then absolutely, I think we can have either hit enter or you can plug in some other service loader to say, hey, go grab this other thing here and request when it's time to load. References probably needs to come from, is this going to be a chain of references? No. This also needs to unroll this and grab what's in there, which means it needs access to the resolver to do it. Okay, we'll figure that out later. That will not come up right now. What we do need is the bindings, though, to get that new scope in place, that item scope. Which means we need a way to push on the stack. Stack is here. Right now we only have, we've got a push root. We do have a push item. So once we're in the binding, we need to call push. And we don't have one of those yet. So we're going to need something that looks a little like the attribute model, but when you give it a reference, it just says, okay, here's what I'm going to be a binding on. All right, so let's make a new type for this. Binding, directive, what are we calling this thing? We're calling it directive. What? Oh, I already made one. Heh. It just didn't, oh, I just can't read. The real problem is I can't read. Okay, well that's, we're gonna have to deal with that. All right, so this is already constructed here. Move this over here. And hide some of these other bits so we can actually see what we're doing and how all the rest of this goes together. So presently we say here's an attribute. The directive attribute has what? It has a name. And then there's going to be some kind of a child to go with it. The previous context is going to be an element. So how do we handle attributes? We say, grab the previous context, assign the current context, visit the children, attach to parent, which is how we render it. So we still have to visit the children because we've got to collect the reference. Let me do a PR for it, and then we'll release a new version with incremental new closure and so on. Yeah, make a pull request to my branch that cleans up the incremental work I've already done and uses this new pattern that I'm proposing here. The other option is, if you'd prefer, I can just make Jackal non-incremental and we'll still get closure and type quit incompatible pre-processing. We'll get those to be incremental. It won't be all of closure, it'll only be bundle. But it's just the Jackal task that I could basically just throw this all away and make it never incremental, or you can take what I stubbed in here and build it out yourself. So, your call on how to do that. And if you don't want to do that, then I will just throw this away. We'll use all the rest of this commit, and we'll say this is the new API, and then we'll do a release. What, are you busy or something? Dimitri is very, very busy. Got a new boss. All right. Visit children. Now we've got to have those children to handle the current context, because now when you visit attribute text, we would just say grab the current context and append text. And if you see a reference inside of there, which is far more likely, we're going to say current context generate append reference, which is this thing here, to say now we need to create your directive. So how do we create a directive? What's the wiring for that? We look at our hand implementation of this. It's bound directive.of has scope if it isn't has scope. So there's two different kinds of directives. We have directives that just say, hey, I am a function, and I take a DOM element, and I take some data that I can update, and I will do something. And then we also have the has scope, which has scope extends from directive, and instead it has this more powerful init method, which is able to say, okay, again, DOM element, unbound fragment is a lambda. We should probably annotate it as such. Functional interface. So this is how do I generate each child given some data, and then the actual data that the current set of data that it will bind to. So we've got a couple implementations of these. The simple one is to create a new scope just gratuitously to say, hey, I've got this property and I'd like it to be the top level scope within this tag because it's going to make it easier for me to write templates. And then we've got this much more complicated one, which is take the contents of this collection, watch them for changes, and run this function here to create new children for each one of them. And so the top level just looks like this, where we say, okay, we need a property that we will close over and we'll access in both of these here. We will listen for changes, and then we'll do the initial binding. And the actual work here of anytime something changes is long. And we will, in turn, attach listeners to the collection to say if something changes in there. We'll have to keep track of it. We don't do the garbage collecting and cleanup stuff yet. That is going to have to come in a later cleanup. So we need a bound directive of, and then we have to decide, are we calling of has scope, or are we calling of? We need to decide what element are we calling it on. That's easy. It's the element that this was added to. So we have to have a way to peek up the stack for that. That's not true. Once we are here, previous context is the parent. So let's see. What other thing do we have to do? We have to attach to parent. It's going to look a little like this before we reassign the old one. And then we say don't assign this until we finish the element we're working on. Oh, right. So the problem is the parser, as it walks along here, it's going to say, oh, there's a UL. Okay, it's got to repeat items. Okay, or repeat content. Okay, repeat contents. Here is your items you're going to work with. Okay, that's it. Back to the UL. Let's append a li to the UL. But we want it to stop and say repeat contents here. I want you to stop and close over all of this because this is the thing you will be repeating over and over again. I want repeat contents to have a reference to the UL and to have this template here so it can repeat as many times as it wants. For width, it will be always repeat exactly once. You could hypothetically make a conditional one. It'd be silly, but you could. Maybe it would unwrap optionals. And then it would run 0 or 1 time. And then in this case, we're running many times. You could imagine a repeat contents that does maps and would loop through map contents, providing instead of index length and item, would provide key value, I don't know, index length, probably not index, just length. So we can't reassign this. We need to leave stuff waiting until we get to the parent element, until we finish the element we're working on. So we need to stop and not do anything else until we get there. Generate add attribute is wrong anyway. It'll be this create method instead, I think. Not this one. This one. Which we call in 2 different places today. DOM elements get a create call, and components get a create call. And when we return to here, we've visited the children. Now we need to how do we say this? Something like this to say if there's a current has scope, now we say create it. We've already got a good method for that. What other kinds of directives do we have, just for reference here? Because I don't think that they need to finish outside of the scope of children. So we've got display if true and display if not null, which will just bind to our display property. And there's no need to run them other times. We're going to pass this to of. It's the template bound directive. Here we are. Of. We're going to say, hey, here's the DOM element we're actually acting on right now. Here's the directive we just instantiated, and here is the property we're going to access. So we can just do a single line for that. But we don't really have a way that makes sense for them to write down here. So let's just make this just general. Directives. We'll just loop through directives. And then we'll clear out the directives once we finish that, which means we're going to have a stack of directives. Crap. Because there could be a loop and a loop, right? And you don't want to finish somebody else's loop. We want to have a stack of loops. Which implies at least that this is now a part of the component, the element model and the component model themselves. And that we need a, not just a create, but a finish. Before we append. Not this one. Sorry. I thought I was looking at something else. And I think that these probably should be non-abstract, only abstract ones. Abstract one should only apply for basically things that everyone implements. Attribute, yes. Component, wrong, but yes. Directive, definitely wrong. Element, yes. This is the only one we've actually got built out. Generate add attribute, we're saying it's not supported for a particular type, and so we're going to do that for create and finish too. Okay, so we'll make these non-abstract. This seems unergonomic. It's just remember, please, that this is specifically what's going to be applying to this code here. This is not user-facing code. I mean, future me is going to hate it, but whatever. That's his problem. Okay, so we first of all have two implementations of this, and everywhere we implement this, we're going to do a finish. Oh, I guess we don't have two implementations of this. We do now. Attribute does not need to create. So rather than having to have some magical return empty, we can just throw this away. Component and element are all that has it now. And now each one's going to need to iterate through its own bindings and generate them for finish. Kind of gross, but I think it makes sense. So we'll come back and do that one after I get this one done. All right. It's going to be directives. I say bindings, what I mean is directives. All right, and now we need a, hey, now you have a directive method on here. And then we're going to have to call the directive to say, now it's time for you to run your create. So I guess we're going to put that back again. Code block, I guess. No, it's going to be void. Okay, cool. Let's go ahead and implement this in the two places that we need it. Because it really does make sense between these. I think that logically makes sense. We're going to say directive dot add directive. And then we're going to say for each directive, we're going to go through it and append it here and ask it to do its create. It should already have a reference to it. So I think we can just get away with something as simple as is that? I can't remember if you want to use as statement with a code block or not, or if that's a no-no. I think we don't want to do that. It's been a while, though. Yep, we don't want to do that. We want to do this one instead. Something funny happens, and I can't remember what it is. Okay, so we're going to chain all those in here, just so that we can make sure to do them consistently in the same place, especially if there's more than one. We're going to go over to component model and do the same thing. Hey, look at that, the to-do's gone. All right, cool. All right, next we need to actually make that create method do something, because we're just going to throw as it is right now. Directive.create needs to be in directive model. Generate append text needs to throw. Oh, it actually can support text. Crap. Let's think about this for a minute. Attribute model, how does it get text? Yeah, okay. So some directives take text, not all of them do. Is that correct? Can you bind? Are we assuming properties? Nope, we're just going to say we're going to throw it. We're going to throw it. And then we need to make a create here. We need to figure out what the type is. We need to figure out, once we get a reference, how to resolve it. So this is going to be the resolver thing. So let's make this constructor a little less terrible. We'll pass in the node's name. So what kind of a directive are you? We're going to pass in the resolver, so you can look up your name and find out what type you are. And then we're going to do like we did for component. The component constructor says, okay, grab the resolver, write it down, grab the name. Why do we want the name later? We don't want the name later. That's for a namer thing. We don't care about that. Component model gets instantiated here. The name is, well, maybe we do want a name. I think we actually, no, do we make names for these? Doesn't look like we need a name for this. And doesn't look like I bound the other ones. You know, bound directive.of. Am I ever calling this? Nope, I'm a jerk. Okay. So I never implemented that if not null thing. Or rather, I never used it. So this is our handmade code to make this make sense, to understand what kind of code we want to generate. Make sure that we get this scope thing right. Yeah, I'm back to not believing this is right again, because we want to make sure we don't append these children to the element. A little more room to pace. That doesn't make me completely disappear. Hi. I've only been here for like an hour, right? A little over an hour. So I think we have to push the directive on the stack and leave it there. I think we have to make the component. Oh, we can't push it on the stack, though. We just assign it to the stack. Right, so we're recursively running these methods, which means we're using the Java method stack, right? This method calls, this method calls, this method calls, this method. And each method is just reassigning this field, and then keeping track in its own method frame of what the old one was. So each method is holding its local variables, and that forms a stack where those values are just kept there. It requires a couple extra, I mean, it seems like it requires a couple extra lines. It's really no worse or no better. You just don't have two copies of the stack that could fall out of sync. In this case, we want them to fall out of sync. We want to say, even though I have finished with the current component, sorry, the current directive, I don't want to give it back. I don't want to give the stack back. Unless we don't want to give it back unless it is a plain directive and not a has scope. only for has scopes do we hold on to it. So we have to say, hold on, this is attribute. I got the wrong thing in here. This should be directive model. Oh, right. What am I doing wrong here? End directive doesn't have a method. We just do that. There we go. All right, so this is awful. I'm not ready to give up on this yet because I don't want to leave it stuck like this. And this is where I left it stuck last time. So if we just don't unassign this, maybe we even ask the current context, hey, what's the directive we're doing? If we say something like, if current context is as scope, bad name, or whatever, then we do nothing, else we can pop that. And then for components, instead of just this, we now need to walk this stack, but we don't actually have a stack we can crawl up here. Yeah, it doesn't matter. It doesn't matter. Current context might be a directive. That's fine. We just don't validate. Hey, was it a directive? Previous context, append current context. Current context is no longer the component that I created, though. So we need to explicitly say, this, I want to deal with the component, not the context. Because the context might be something else. We might pop more than one thing off the stack at the same time. This is hard to read. I don't like it. As long as we got a local for it, I'm going to reference that instead of current context everywhere I can. Here's where we reassign that to say go up the stack to whatever it was before us. We got to do the same thing here. Okay, so now we only assign it, but we cache it, replace it, restore it. Cache it, replace it, restore it. The main place where this breaks things is if you have attributes that you need to attach to the parent, which we now don't have a reference to. So when this tries to do hang on, is this backward? Is this method backward? Previous context. No, yeah, so previous context is not the directive, it's now the DOM element. So this is going to break. So maybe we just need to say, hey, can we pass this through to the nearest element that's our parent? Remember, we can't put directives in directives direct. Wow, this is bad. We can't put directives immediately into other directives. They can't have a parent that is a directive because you can't say a loop and a loop on the same element because you need some DOM contents to work with to have the scope make sense. You can't just introduce arbitrary scopes like that. It doesn't make sense. So we probably can get away with this. Override generate add attribute in the directive model to propagate this to the parent. Okay. The name now is the directive name. The component model is, this is what we did before. We said grab the directive name. Resolve directive from the directive name because it's going to know the types of all of them. We're going to make a variable called directive type. Split. Make this a private final field. We're going to want parent to be a field. And resolver. Okay, parent is now how we append attributes. We propagate up. Generate append reference. Nope, that won't happen. We're just going to track that reference. Yeah, we'll just return code block empty, basically. And then okay. Append text will blow up, and then create will do the heavy lifting. All right. So now we need to figure out what type we were, what kind of directive we were. We've got the directive type already to check this. So something to the tune of if resolver is has scope directive type. All right. So bound directive, we're going to move over here so we can see it. We're going to append a single line, which is roughly $t dot of. Now we need the parent. So create no longer makes sense because now we need the name of the parent. We already have the parent in here, though. We can ask the parent for its name. Can we do that? No, parents don't know their own name, but they do know node expression. Is that what we're looking for? They do know how to refer to them as an element. Perfect. So we need to have a reference to the element, $L. See, because that's the argument here, element. We need the directive instance, new $T, and then we need the reference we're binding to, which is going to be its own issue. The reference we're binding to. We'll just put L in there for now. And then we close parentheses because we write sane Java. And then we start chaining these things together. We say bound directive dot class. So now that is the type that will be written here. This way it does imports and junk for us and still makes readable code. L is the element itself, which is how we'll say parent.node expression. The second T is the type of the directive, which is this directive type here. So we're going to get a nice class for that. Class, nope, class name dot get directive type. Now there's a small problem here with generics. I'm not sure this is going to know how to read generics out of type mirrors. Let's see, mirror.accept with type variables. But it takes the type variables down here. Visit declared. I'm not sure this is going to give us our diamond operator, which is what I'm really hoping for here. As an example, we get a beautiful diamond operator here where all the generics are inferred value. We get this nice hover of loop item scope item view model by virtue of just referencing this one here, which is an item view model, and the generics of this being, you know, unattractive, but usable, has scope. So just by putting these generics in here properly, Java's type inference is able to figure what value should be and therefore is able to resolve these things here. I am not 100% sure I can get smart when I build this myself with my own resolver, so we may have to make the resolver a step dumber and just say, hey, just trust it's going to be there. Or synthesize some extra Java to say, hey, would you go do this lookup for me? And I'm just going to trust it'll work. And then it's on the lookup thing to generate good working code. And then somehow use that to get back to, hey, did this actually make sense for whoever it is who's using this? Okay. 1, 2, 3, or 1, 2, 3, 4 bindings. Okay, so we need the last one, which is the property itself. The property itself is going to be something like reference. We'll just put the string reference in there as is for right now. That's totally wrong, but it will get the right idea. No semicolon. Okay, so that's vaguely sort of kind of maybe right. I don't know if we're actually using this anywhere yet. Hard mode. Technically, this is one statement. Unfortunately, there's a lambda in it. We need to say of has scope, the UL, the instance, the reference, the UL here meaning the element. And then this lambda thing has to happen to grab up all the DOM contents we found, which means the directive needs to actually accept those. Look for DOM children, basically. And then in turn, it's going to effectively just create a fragment with all the children it finds. So I think it's actually appropriate to move this to the top. And all the items it gets, because this could be more than one, and then return them here. So I think we're going to need a code block that we are cumulatively adding to build this up as we go along. Because this is very similar, by design, very similar in structure to how do we append this to the parent itself, which is what we're generating now. The wrong code we're generating now is not being found by my IDE. Here we are. So this is wrong, but it's close. We got this li. We want this to be nested, and it's going to yell at me here in a minute. The UL goes here. The new repeat contents goes here. Easy, easy. The slightly harder one is the get view model.items. Okay, IntelliJ actually figured that out for me. And then now we have the new item in scope. Because remember, this is the compiler error we hit. This is what we started doing all this here. Now we have item. No, not item. We need a name for this. We need the namer to propagate into here because we need to have local names for this stuff. We can't just call it item because then you get item.item, right? Value. We call it value. Value.item. We don't want item.item. We want value.item. Okay, that's not terrible. We'll call it value. So we need the namer to kick in here and say, hey, we're building more names. Semicolon. Take all this junk, put it in here, and then prefix value dot, because now we can loop and we can run this many times. This template now makes sense inside of here. This one won't get it because it's going to say, hey, I actually need get viewModel.recipient.phone. That'll make sense. And then once you got the li, we don't append it here. We say first at the top, I'm not going to use var in the real code because it's harder to read, but autocomplete doesn't really behave in the what am I doing? Generated code is nicely. And then we don't have this at all. Comment it out. So that's the transformation we need to apply here. The code we've got is almost right. It's generating this stuff almost exactly right. It's doing internal bindings. It just doesn't quite have the scope lookup here because it hasn't introduced a new scope. So we need to push onto the scope and say, hey, there's a new thing. Its value, its type is, please infer this magically. I don't remember how to do this. I had a plan for it. We'll get there. All the rest of this other junk here is easy. You know, just don't give me generics. Just do it arbitrarily. We know how to reference this. It's going to be easy. Now we have to infer this type so that we can properly push it onto the stack. And then we have to do a line before and 2 lines after in a lambda. Okay. Has scope. We're going to pretend that that's a thing. We're going to make just a single statement here, but that statement is going to have a statement nested inside of it. It's going to be $t of, oops, hey there, we need some quotes. $t dot of has scope. Let's go over our arguments. Element, directive, just like before. Property, just like before. Unbound fragment. That's the lambda. And that's going to be $L, new $T, $L, and then code block goes here. I don't know what code block is. We're going to need a name and an arrow to a block. I don't know, $L for a block. We'll just do value for right now and block. Make a code block for that. Oh, this is not going to work. We can't do append reference because we actually need to accept references inside the contents too. So we need either a separate model or we need a way to tell only the first one is a reference. All right, we can get along with that. What if we made a element model? Nope, never mind. That's nonsense. Yeah, this is close. What if we made an element model and pretended it was a fragment and just said it can't take attributes? But we still appended regular bound text to it. We just have to give it a name. Say we're propagating the namer into here because we don't want any child things to reference parent things, and it would not be a good thing if two different things in different scopes. Sorry, it would not be a terrible thing if two different loops didn't reuse names. It would just make readability slightly better if we didn't bother with it. So we'll propagate the namer in here. Yeah, this isn't terrible. This doesn't actually care that it's not a DOM element. We just have to make sure to build it as we go properly. Okay, so we're going to pass the namer in also. Which I think is a private type. No, I guess not. All right, there we got a namer reference. Let's go fix the compiler we just introduced. It's easy because we've already got a namer right here. Now we can make new names inside of here because directives are complicated. So value we don't need anymore. We can now say namer.next. And then we still need the lambda body, which has to have a return in it. Fragment. We need a name for the fragment because it has to be nested in here. That's irritating. Right? Because you could have this lambda here, you could have nested lambdas in here, so you can't call them fragment, because if you put another one inside of here, I'm just going to reuse the, well, I'll just use the li. That's technically legal. If I return fragment here, that would be bad. It's not called li, it's called item. Whatever. And if I reassign fragment here, that would also be bad. Right? Java won't let me do this. It says, you've already got something in this scope. That's confusing, just don't do it. As opposed to JavaScript, of course, where you can introduce new scopes in every function and they hide each other. Which is, of course, I mean, I don't know about of course, but which is why we get into the situation of this being non-optional, you know, as opposed to Java where it's unambiguous. Okay, so we need to say the namer needs to pick the fragment name, or it's not even a fragment name. We just return the element here. So maybe we just say new element model with a name. What's the name of the, no, the name of the, oh, see, it wants to do a tag name. That's not quite right. There's so little code in here, it'd be really nice not to delegate. I mean, it's going to be 2 dozen lines, maybe 3 to copy it. But this is wrong. This create call is wrong. It can't be create element. It's got to be create document fragment instead. Because I don't think there's such a thing as a tag. You can say, hey, it's a document fragment. What do we got here? 1.5 hours. There's a donut upstairs with my name on it. I mean, not literally, but so it is Valentine's Day. I mean, you could get that, I guess. I'm gonna go grab that donut. And then I'm going to come back and I'm going to make a decision about whether or not I'm going to make a new type that extends element model and has a slightly different create, or I'm going to just copy the code out of this. The name is known, that's easy. The tag name will be something special because tag name is only used right here. We can't have directives, so that won't be a problem anyway. We won't do anything here at all. And we'll just need to loop through and do our create finish right here in this code block builder here. And then finally return whatever the name is. So it'd be something like, I guess I already started it here, something like namer.next fragment. That won't exist. We're going to make that a field. Whoops. Hang on. I hit the wrong thing. Yeah, there we go. Split. That's what I meant. And the fragment can itself be put here. Oh, is that going to work? Because we're going to have all the children now. It's going to have already appended children. I don't think it's as simple. Because we gotta capture all of the contents. This could be okay if we just keep the body, the lambda body. Then we just say every time something gets appended to the fragment, we'll just put it in here instead. And then we can just say return $L, and L in this case is fragment.node expression, which will just be the name, because it's always a element. See, it's always the name. We just need to make sure that everything ends up inside of this code block instead of ending up out here. Right, because what this is going to do when it says, hey, I see a new element, I need to append it. When it sees that li, that top li here, it's not going to save it up for this lambda here. It's going to say method body.add. Which starts to suggest that the real problem now is we don't want to call super visitor to visit, not this one. We don't want to call super visitor to visit children. It's not our children though, it's the parent's child. Yeah, at this rate, every model needs to keep its own reference to the code block builder it's writing in. And then instead of this local for method body, we just say current context dot grab your code block and write something to it. Because now we can scope it into here. Okay, I'm going to go grab that donut from upstairs. I'm going to think about this because I think we're very close. We've just got a couple little bits of garbage like this and rewriting all this method body to not be a local, but be part of the current context. And then we just reassign it as we go through here. This is going to be a little messy. Here's our is-has scope again. Okay, donut time. I want a donut. Donut will help me think, right? That's how that works. Let's put up the be right back screen. I will be less than 5 minutes. The coffee is almost empty, and I need a donut. And then we're gonna get this. This feels close. This feels very close. We don't have the types being resolved properly, I know, but we're gonna get there. Okay, back in a few. There you go, Justin. All for you. It's gone now. The last Valentine's Day donut was already eaten. So, I just got a plain donut. But it'll be fine. Alright, so the ugly refactor here is pushing method body into each model. And then refactoring model so that each of these methods that would have returned a code block instead appends to its own current locally scoped code block. And this enables us to put attributes and elements and components inside of lambdas because they always know where to write their contents. The trick is we need to be able to share these. So we want to change the constructor of these so that when you construct a component, you say, what? How do we do this? The root document needs to have a method body, right? So we still need something higher level. And we're not going to put it on the stack like this. We're instead going to change each of these calls here, these method body.add, to just let this append here. So previous context itself. Okay, we just use these null checks. These null checks are all we need. Okay, this is not so terrible. Oh no, it is. It is still bad because dang it, didn't quite work. We would need to ask, we need something like previous context.getBody.add previous context that append. In the case where previous context is non-null. In the case where previous context is null, assert name equals root. Is this backward? That's what it should say. in the case where name is root, we can just call return root at the top level here. And then our call to finish, let's see, we put the create call here and the finish call here, is what would have appended the code body here. It's not making sense. Let's try rewriting model. Let's do a quick stage here. Wait, what? Oh, no, that's correct. That's correct. Okay, so now we're going to do a quick to let lambda bodies work. Doesn't build. How bad is my recent history? That's the only real bad one. Okay. Okay, cool. Let's give ourselves room to screw this up. We have a body. Sometimes we're going to need, I think, to take the body from the constructor call. Other times we're just going to inherit it from whatever the current previous is. We got two real cases to worry about. We need a directive model to generate its own fragment with its own method body. Let's move this to a method. Because that fixes this line over here too. As soon as I cast it. It was pretty good. Old-fashioned sour cream donut. Our current donut shop is closed for renovations until like April. March or April. They closed end of December. And it's been a long time. So it's only a grocery store donut. But it's okay. Not too cakey. Alright, so this is... needs a comment here. Justin, you must have been AFK, because I actually held it up with the camera for you. Or maybe you saw that and you just... Yeah, I mean, Dunkin's makes good donuts, I guess. It's not even part of their name anymore, no. They think they're a coffee company. They're wrong. Or maybe I'm just too much of a coffee snob. Yeah, you must have been out. I came off, be right back, and had the whole plate held up to the camera. And... yeah, it may be a where you live thing. I don't think there's that many around here. I mean, we got some, but Dunkin', Starbucks. We've also got Caribou Coffee here. Doesn't exist in a lot of places in the US anymore. They got bought by Pete's, by the same company that owns Pete's. Didn't want to outcompete themselves. It's still good, but I don't go out for coffee a lot anymore. Yeah, but why would you? When I was in college, we learned that if you go to a Dunkin' Donuts really late, and it may not be true anymore, they got donuts to get rid of. As long as you get there to like the last 10 minutes before they close, they'll just give them away. Yep. Free donuts. Free donuts are where it's at. We're not quite $2 a donut at our really good shop, but it's getting there. It's been creeping up lately. Barrels? It comes in barrels? Alright. So if this idea is correct, this is going to get pushed up to the super class here. Yeah, I'm just being a jerk. I don't know if I want to make this actually protected. We'll just do this for right now. And then we'll rewrite each of these to be void. And make sure that each of these individually makes sense without this. All right, so let's try an element first. And let's focus on what happens if you append a child to it. If you append text to it, it's going to be get body.add statement. Right? If you append a reference, same deal. Oops. All right. And then add attribute. Okay. So aside from, all the references to it, we don't even know how create is going to get used yet. Let's leave that one alone for right now. A little worried about this one. We'll come back to it. Component model. Once again, a little worried about that, so we'll do the other ones first, where we actually append contents, and just replace each of these to be a get body, make sure all those make sense. We still don't know how we're getting the body initially to do the setup, but generate append reference, return null. Okay, so that's just a giant to-do. I'm guessing it looks a little like the other one, child accessor get, combined with this. It's just going to be $$L, $L, add. Yeah, that looks roughly right. Okay. We got a to-do in this one, so we're not going to worry too much about that. But get body. Okay. Yeah, see you later. So now the question is, how do we create the child nodes, and how do we get our own code body that we're appending to? I mean, we could just make like a new set of curly braces. What's the direction relative to the video? Yeah, whatever. Open, close for each element and just nest them. Because you're allowed to do that technically in Java. I mean, anywhere you want, you can just say, hey, and here's a new scope. And this lives in this scope in here, so I can indent it and do things like that. I don't want to do that for readability. Kind of don't want to do that for readability. It's not code anybody would normally write. All right. So it's the question of where do we get this to begin with, and that's where it comes to this directive model. Say, never mind create, we'll do the append. We never did finish this, I guess, anyway. Because when it makes this new element model, that's where we're going to want to pass in the lambda body. And that's where element model is going to say, I optionally have a code block. Maybe I always have a code block. And I will call super block, which means I need a super constructor. Okay, so now we've got that assigned. That's wrong. I think they might have overdone it with the builder thing and some of this stuff. I mean, unless you're really actually holding on to these references, I don't think that's likely. Okay. So now we've got the ability to say, hey, this new fragment has to have a special scope. It needs to pass its scope on to its children when they're created. And now we're back to the step saying, given a component, make this public. I think we actually want it to be public. Unless we've got some like as code body. Is there any interface this implements with all this add statement stuff? No, there really isn't. Add code using named arguments. Ooh. Named arguments specify their name after the $, followed by colon, and then the corresponding type character. Argument names consist of A to Z, 0 to 9 underscore must start with lowercase. Is it going to generate names for you? No. Okay, not what I thought it was. I got a little excited there. So, previous context, we can generally say, let's do the element one instead. We can generally say previous context.getBody. But if previous context is null, then we can say previous context is null. This is awful, and I apologize. Method body. This is the only time we're going to use the method body. Because now we're in the outer scope. And then once again, we got the null check down here. Let's unwind this and apply it to the next one down also. Component. This is atrocious. It's not a new constructor, just modify the existing one. So that vaguely compiles. Then we can start grabbing these. Okay. Current context equals element. Oh, yeah, you're fine. It's not quite the same, though. It's very close. Could we actually... Yeah, this part is all looking very similar, actually. We'll see if we can reuse that. All right, generate append text is just going to append to whatever it can right now. Generate append text will do something unique for... Yep, it'll just add the attribute there. I guess we don't even need this then. Never did to begin with. We'll get back there because it's missing its super call. But this won't even append anything anyway. It doesn't really need a body, I think. Generate append reference. So append reference is implemented in attribute. It just grabs the reference, but it doesn't use it yet. It's not until we finish the attribute down here that we actually use it. Generate append text. Right, if it's already an assert is empty anyway, that's just weird. I don't know. This is looking better in general instead of worse. I was expecting it to look worse. We still have that ugly ternary at the top to say, hey, am I at the top of the stack or not? And so do I append directly to the body? Okay, we are pretty close here then. Let's just round up a few of these remaining things. Create call, for example. Keep getting pop-ups over here or something? It's getting distracting. Is there something important I need to look at over here? So we deliberately gave up on this create and finish, which is kind of a problem now. Because we need to append to the parent this create call. Elements and components need to be actually constructed before they can be used. We kind of bail on actually handling attributes because when you append an attribute, we can just say set attribute. There's no scoped thing we have to keep track of in the attribute. I don't think there's anything else we need to read from here. Get the expression. It's just going to be a lambda in one case and a string in the other case. All right. So it has its own body it can append to. So there's no reason that create and finish can't simply do the same trick as everything else was doing. I think it's going to be a rude awakening, I think, when I actually get it running. directives, I guess, all stack up at the end. Does that even make sense anymore? The important thing is that they all run at the end. Yeah, I guess that's the important thing. You're unhappy here with the directive model. It's okay, it's a void anyway. Void anyway. Parent, add attribute. Yep, attributes won't pass into our fragment. Fragment will only be used for the other append stuff. Generate append reference. Okay. And I think we want to assert that reference is non-null by the time we start appending text. Probably an assert is not strong enough, but we'll go there for now. This is wrong. The directive has to be written in two scopes. Its children go into a child scope, but its own contents goes into the parent scope. So we actually do need to get the builder passed in for the outer scope. Okay, so we're going to pass the outer scope up and need to take care to say, when do I call getBody? And when do I call lambdaBody? So lambdaBody add statement means I'm about to build the whole thing, and then I take the lambda and I print it out into the getBody. So who's calling create here? Directive.create. I guess we don't do a finish then anymore, although really it's a finish. I like that better. Let's go to element model. Oh, now we're getting irritated here because it's just finished now. Right? I mean, it's not irritated, it's just weird. Element model, component model needs the same thing. It is now just, the whole thing is just a loop. And then directive.finish. Because logically that's true. Okay. Pretty close now. And we need to create this with the current parent's body. That way we can inherit it. We just have got a couple of these left. Let's see, when you do a finish, it has to go out on the body. We have to append this in the lambda body too. Hey, if we don't call create, it doesn't matter. I don't even need to subclass it. This is going to be the create, so it's going to be type of the fragment name, which is a literal, equals factory dot create document fragment. It's technically will work. It's kind of ugly. Okay, so now we've got it in the lambda body where we scoped it in to give it a name, and then we can return it at the end because we're basically saying we're finishing, we're all done now. That's going to be the end of that. But this only happens if we are has scope. Otherwise, fragment will be null, I guess. And we just better be prepared to accept that. Okay. This is where we left off. And finally, we need to implement that. We hadn't even done it before yet. Let's go do that. I guess that's it. I'd be really surprised if this works. Let's just return true. And we can worry about this in a minute. It just, does it implement an interface or not? Something's unhappy here, just because I made this garbage generated code to make a point. All right, what do you think? Approximately 0% chance that this even makes it to the point of being debuggable. Compilation failure, okay. Error writing generated type. Generate append not supported for directive model. Okay, so we need a few more overloads. That's reasonable. We don't need append directive. We need generate append. I don't think we need node expression. It's really just that. Kind of cool. We'll put the same assertion in there just to make sure that nobody's putting a component or an element before we got a reference that we're going to loop over or handle in some way. Cannot invoke type mirror except because mirror is null. Yay, Java 17. Giving us helpful stack traces. Boo, Java, for not giving us clickable null pointers. So there is something null we can't call except. All right, I guess we'll hook up the debugger. I'm guessing I've got a breakpoint for nulls already. Yeah, no, I don't. Just for, hey, it blew up. All right, well, let's just get the stack trace here then. That should be good enough for the moment. Stack trace. Have a poet name. In the finish, we had something that was null. Some type that was null. Node expression is a string. Directive type is a null. Oh, that would be bad. It's probably directive type. Probably. I never implemented resolve directive. No, it's resolved. It's here. Let's see. Compute if absent. Oh, okay. This is what we did for components to make them fail faster. Hopefully, it's just a matter of I didn't hook it up. We'll see. No component registered with type repeat contents. That's right there, so it's not looking up properly. The resolver isn't working. Component and directives loops look the same. It's looking up components correctly. Directive should just be, hey, grab all the values. Cast to declared type. I know that's ugly. Oh, redundant even. Do you not need that? What did I... Oh, you just want to cast? Just a straight up cast? Okay, that's fine. Collecting a map. Assign to directives. I guess we'll put a breakpoint there if that throws. We'll put it in the throw lambda and try it again. This is, yeah, whatever. We have repeat contents. Oh, it's not stripping the name off? Did I do that wrong? Class name get toString. Huh. How are components working at all? How are we doing this if we are... Directive stack components are empty here. That's weird. All right, here's the other one. Directives, components. It's a string to a class automatically. And it's a class type. Oh, because I don't actually have packages on this stuff. Because I did a bunch of these in the default package, just to hack it together quick. Well, that's not helpful. All right. I had a VPS that had some weird hiccups. And they're just saying, well, that's fine. You know, the kernels might just do that. Get stuck for a while. And telling me to run all kinds of crazy tests. Okay, we'll figure that out later. Resolve directive needs to, so all these need to say, let's strip off the name, class name.get. Instead of toString, we just want the actual name, simple. Let's try that instead. Okay, now we're getting somewhere. Well, that's not how we write code blocks and lambdas. How does Java Poet handle lambdas? Or, I mean, not the way I just wrote it, obviously. Uh-oh. They don't? Oh. Okay, so it looks like you can get around it. make your lambda register takes a $L literal, this, and a code block, but we can pass in a literal for add statement. Is that not what I'm doing? I thought that's what I had decided to do. Add statement. Add statement. This is the lambda. Oh, we never passed a value in. Okay, to do. We can't do it here. We got to do it. Okay, we'll come back to that. It's not going to compile, but it's going to at least look vaguely right once we get the hang of this. So the lambda body just needs a build on it, I bet. Let's see if that helps. Still not expecting to compile. Oh no, now we're back to this. Error writing generated type statement. Yeah, so we had this before, where this is just what happens when you start putting code blocks inside of code blocks. And they have a code block. Inside of a code block, and that's the same thing I'm doing. They're making a code block, and they're trying to pass this code block in. If we use method add statement, the code block will generate open and close. You can use code block add statement, and code block has its own add statement to generate that. Code block will not become real code until we call code blocks B's toString, and at that time illegal state exception will appear. So the real problem is not generate a lambda inside a statement. The real problem is in a statement, another statement exists. I'm having a real hard time with this. Reading this. I have two ways to avoid the solution. One is before add statement, call code block B's toString. That we can do. Build toString. Another is do not use add statement in B, use add instead. Okay, so if we only used adds, we could get away with it. But I can't do that because I don't control, I mean I do, but it will be harder to control this all over. So let's just try a toString. And we'll put a note about this comment. This is very close. We need curly braces. This is very close. I put that in the wrong place. It should go at the end. And lambda body up at the beginning should have let's see if we got it. That's close. It should have a new line there. create document fragment, return the fragment. It's still putting the li out here. So it's appending to the wrong place. Okay. We'll put a new line right here. And then when we add a child... Oh, I see. We need to always return this for the body. Okay, let's find that all the calls to body right now and replace them with super dot body. Because that's how we append our wrapper stuff. But then we override get body to return our lambda body. That's it. I mean, it's not it, but it will get us recognizable Java. Check that out. All right, so now we've got this bound directive of has scope. The types are all wrong, probably because I just need to say, hey, reify this here. Loop item scope of T, it doesn't understand what that is yet. Items is not a proper reference. This needs to be get view model dot items, and that still doesn't have it. Items, value, okay, so that has the right type. This doesn't seem to, but that's okay. Value then can be referenced here. Okay, so we need to make sure to nest this. This is part of our, make sure to push this on the scope stack so we can do proper lookups. And this one also is not doing lookups. Cool. So those resolve and make sense now. We just need to fix how that's resolved and push a value onto the stack. And then fragment append and return fragment. That looks almost correct. Let's see if we can get a couple of those fixed. Tab panel is the same problem, I'm guessing. This indenting is a little squirrely. It only has an X on it. It lost the other elements? That's weird. What's this supposed to be? Tab panel. Let's put this over here. It's supposed to be a UL with an LI in the repeat contents with a reference to children. Oh, look at that. It got two scopes. It nested both of them. Is that correct? Display if true should not be a... Oh, look at this. Okay, so this is a non-has scope, but it generated a has scope because I'm always returning true. Okay, this makes good sense. This is just supposed to be a Boolean here. It's not supposed to have a lambda at all. But I screwed that up. So we'll fix that. That'll be easy. But let's fix our stack first, since that'll be hard. So now we need to say the accessor is lambda arg, and the type is, we don't know. We don't know the type of that. Declared type. We're going to need to find a way to resolve that, because that's going to be our real killer bug here. So if we are a has scope, this is actually too early to push that. We don't want to actually push the scope until we have finished resolving the reference, otherwise you might get stuck in the child reference. But I'm going to handle that with a to-do. And then we're going to use this value name here to build our lambda the rest of the way. Then we don't need it down here. And I can just say the entire lambda goes there in one piece. Okay, so now we need to get something to pass in here for a type. I don't even know. What are we going to do here? The resolver has types and elements, so we could ask it to look up this type. Let's see, getting kind of late here. I need to check this. It's almost 3. When we do the get as scope, this is the time we can probably look this up. So we've got to be able to ask it at this point. The directive type. No, we can't do it yet. We can't do it until we can resolve the reference. We can't actually work out the type until here, because this is what we're going to ask for its type. And its type will be our answer. That's the, it is a, no, it isn't our answer. It's not conclusively our answer because we have to wrap it. Okay, so back up. When we make a loop, we need to say this returns a property of a list of item view model. An item view model is just what we happen to describe here as what's an item look like in my, I don't know, line items for a invoice. But value here is not item view model, it's loop item scope of item view model. And that's what permits us to say value.index to get the current integer index and value index to get the length. Value item, in turn, is our item view model. Well, get value is. That's what we need to read into to grab this. So it's not enough to say, hey, what's the type of that thing, and use that to figure out value. We actually need to examine the type of our has scope. Say, take this thing here, cast it up to a has scope of S and T, and figure out what to do with this. Because S and T are not necessarily related. T is known. T is what we're going to get out of T is what we're going to get out of the property itself. This object property T. We can read from the actual property we're referencing right here, items. It's an object property of observable list of item view model. Okay, that is assignable to object property of T. And that will make T into you look at the inner part here, observable list of item view model. Great. But then we need to go the next step of saying, okay, now given that, make repeat contents generic on something and ask has scope what that something is. If T must be item view model, what must S be? And I think this is what's going to stop me for today. We're going to need to push this down. Lambda arg is needed for both of these, but that's okay. I can do them both later. Yeah, this is okay. I can move this. I can push this down into here to say so I have some notes somewhere that determine how I was planning on reading that. Let's see here. There was something else I was going to remove. Yeah, this easy mode, hard mode. It turns out not to be hard after all. We're going to keep that note in here so that we can figure that out later. Return L, which is the note expression, unindent, add curly braces. Document where we got this trick from on this super, super long line. Get rid of that snarky comment. We're pretty much down to this. Need to work out what that type is going to be. And I suppose handling generics there. So if we could just substitute something in there, we could have it mostly working. We got to fix some other lookups to resolve those. Yeah, I'm gonna punt the rest of this for next time around. I'm gonna find my notes and figure out how to populate this. This is gonna be some irritating trick here to do type resolution, if I can find the notes on it. And then we'll be back next week. I think Justin said he was aiming for Thursday, Friday. Just told me. Thursday or Friday. Okay. So we'll see what he's got up to this week. I'm guessing more live grid stuff. I'm probably going to switch gears next week and do some either CQ engine, which is a in-memory Java query engine that I played with once upon a time to see if we can get that back working in Gwt, maybe Jackal, and maybe see if we can do like a web worker thing to load data there. That was what I originally used it for. Yeah, so that might be what I'm playing with next week. Otherwise, try to learn some of how Domino does async loading and see if it makes sense to hook that into CQ with a web worker and just say, hey, if I download a megabyte or 100 megabytes of data to the web worker, can we get the UI promptly giving you information about them, making, you know, all the hard work happen off thread. So, oh yeah, I need to fix this so it doesn't return true all the time. All right, well, that's it for me. I'll see you all next week. And I'll see Justin on Friday. Thanks for hanging out.